Guys, everyone, please respond. Like there are nearly 14 students are there. Okay. Okay, only 4 students are giving the response. What about others? So guys, I am repeating the question. How many of you installed Xilinx Vivado tool in your laptop or any personal computer? Okay. Only 5 students responded. What about others? Very good. Okay. So guys, if you not installed, try to install by the end of today. Tomorrow onwards, maybe you may start coding on Vivado. And so have you started seeing the playlist I provided? So for basics and all. So I think hope you in the LMS portal I provided some playlist related to basic Verilog, but just referring and all. Have you started referring that video? Okay. Yeah. Hope you guys started working on it. Okay, let me start today's topics. So we are going to work on today's Verilog. So in general, I have a question for you. So how many of you know what's actually Verilog is? So what's actually why we are using Verilog? Before proceeding the session, what is the necessity of using Verilog? There are so many programming languages, right? Like C, C++, Python, even System Verilog. So why we are using Verilog here? Can anyone unmute yourself and please respond?
It's a hardware description language.
Okay, it's a hardware description language. So what actually hardware description language means? So Varsha said correctly. So what's actually hardware description language? Why not C we are not using? Okay. Let me start my presentation. Guys, my screen is visible to all. Can you please respond, anyone?
Yeah, it's visible.
Yeah, thank you, Varsha. So, guys, today in this session we are going to cover the topics like introduction to Verilog, why we are using actually Verilog, and some operators related in Verilog, and what is actually continuous assignments, and how the hardware is going to be implemented in the continuous assignments if used. So let me start with the slides. So why we are actually using Verilog? So as I said, Varsha said, actually hardware, Verilog is a hardware description language. So like see, whatever the coding you are doing here, like it's code actually converted to the hardware. So hardware, whatever the like motherboard you are using, whatever the elements you are using, what are the chip you are using in that, actually everything before fabrication, it's everything the logic is written in Verilog, right? And so it's actually used to model digital systems. So what are the digital systems you are using now, like mobiles, whatever the computer devices in TVs, washing machines, everywhere chips are present. So for designing chips and all, we are using Verilog language. So it also supports RTL design, gate level, behavioral modeling. So we will further discuss what is and what and all this and all. So why it is very important in industry? So it is used in ASIC chips as well as in FPGA design. So see, what is ASIC means? ASIC means application specific integrated circuits, whereas FPGA means field programmable gate array. So ASIC means, so for particular application we have a chip, but it's not programmable again. And again we have FPGA. FPGA means it's actually again programmable. We can program it again. FPGA means. So you can use, like, the product based companies and tech giants called Intel, AMD, Nvidia, Qualcomm. Every way the chips are going to be designed, and actually every day the complexity of the chips is increasing day by day. So they are adding that, they are actually keeping, let's take this, there is a chip, so it's performing A plus B operation. So other guy will do with a C OR operation. Like this, day by day the chip is going to be, actually logic is going to be implemented. So like that, chip area is increasing little bit. Like that, our the processors are, why we are getting updates in the processors, they are taking the chip logic previous chip logic, and they are adding some more logic and making the new chips. From scratch onwards, they are not designing. They are taking the previous logic and they are adding some more logic, and they are fabricating the chips. Like this, actually, industry is working. And processor, memories, controllers, this RTL design, this Verilog is actually using. So, like this, we should be aware of Verilog. So, in Verilog also there are so many types of codings and all. So the basic thing is, as we studied in the BTech level, behavioral level, and RTL level, gate level, and switch level. So each and every one have some importance for the, it's actually like styling of write the code. So we'll go further. So see, so basic module structure. So actually Verilog module structure actually starts whenever, see, there is a chip. When the chip actually knows the hardware is start, the hardware is end. When we are going to start with the module, if you start writing the module and give some name, then we are saying to the simulator that to the tool that we are going to start the hardware, and at end we write end module, right, at last. This is actually saying that I am going to end the hardware logic. So like that, we have to start with the name of module and end with end module. Inside we can write our own logics with the so many constructs we have, that we will discuss further. And see, this is a basic example. They are saying they are taking actually module and module name, as we can take any module name. They are taking input A, B, and output Y. So they are taking as internal signals. So they are developing actually AND gate. So what actually AND gate? Why we are using assign here? So they have so many dots. So we will going to discuss further. And module represents physical hardware. See, as I said before, module, if you start writing with the module name, it actually represents a physical hardware. We are going to implement a physical hardware. So see, so before going to actual coding, we have to be aware of what are the data types. What are the domains? There are, in every language we have some data types. First, if we learn the basics, then we can go further implementation of hardware. So see, here actually wire. Wire actually means, let's take there are two blocks we implemented, or any two properties we have taken. So for implementing connection between them, we need a wire signal. So if you write wire keyword, then definitely we are going to connect them. Like we are giving some path for data transfer. So like that, we should use wire data type. It's actually name and reg. So reg means, if you write reg A, let's take reg A. So reg A means there is like a register which is capable of storing 1 bit. So we are defining that register with the reg and with the name of A, like that. So let's take our design. Let's take, everyone having so many ideas to develop the designs. So first of all, we have to take a top module. So first of all, we define what are the inputs we have, what are the outputs we have. Inside we have so many wires, registers, whatever it may be. But overall, we should have a logic like what are the inputs we are giving and what the outputs we are getting. Like that, we have to define, right. So for that, we have to use input and output keywords, like that. And see, the operators are categorized into so many types: arithmetic operators, logical operators, bitwise operators, relation operators, reduction operators. So let's explore them. So see, what is the arithmetic operators? Basic operations. So we will discuss just ignore what is assigned here. We'll discuss this one. So just we are taking a variable and we are doing A plus B. So this is symbol represents plus operation. This these basics and all Star represents multiple operation. So what the hardware it will create? So we are just writing some logic here, but inbuilt it will develop into hardware, right? So what it will develop? It develop into adder circuit. You know, right? Like the circuits you see while you are studying in BTech, we will see this type of circuits. So this hardware can be implemented like this, and subtractors similarly like this. Symbols will be created, and hardware will be developed. Multipliers. So like this, every line of code have the specific meaning and specific hardware implementation. So see, this is bitwise operators. So bitwise operators is nothing but, let's take A is of 4 bits and B is of again 4 bits. So if you want to try bitwise operation, so let's take we have 1 0 0 1. A is defined as like this, and B can be defined as 1 1 1 1. So bitwise operators means every bit can be manipulated. So these 4 bits can be manipulated into new bit. So see, let's take, we are assigning C equals to A and B we did. So it will do bitwise operation. So 1 1, it will do AND operation. It will give 1 0 1 0 0 1 0 1 0 and 1 1 1. Like that bitwise operation will be takes place. But before logic, okay, this is normal operators. So this is bitwise operators. So every bit can be manipulated using this bitwise operators. Similarly, we have OR operation, we have XOR operation, and we have NOT operation. So you know how to use NOT operation. What you know, you are aware of XOR gates and all, right? The same behavior can be implemented using this logic and all. Each bit processed independently. So all bits not manipulated at a time, not. So each bit, like every bit can be manipulated. Now reduction operators. So what actually reduction operators means? So let's take, there are 4 bits or 5 bits or how many bits, n number of bits we have. So all bits can be reduced to 1 bit, either 0 or 1. So that is actually reduction operators. So if you use AND of A, let's take AND is there 1 0 0 0 1, it's A actually. So let's take this is as B. So we are assign B equals to AND of A we are doing. So AND of A means what? It will do bitwise AND. What I said, it will do bitwise AND means it will do this AND operation. So 1 and 0 what? AND we will get 0. 0 and 0 and again 0 and 0 1 0 1 we will get again 0. So whatever what's the result we will get at last, we will get 0. Like this bitwise reduction operators will work. Similarly OR operation, XOR operation. So at last continuous assignment. So I am saying right. So why we are using assign statements? So what is actual assign? Why should use assign? You can get the doubt. We can write directly like this. So what if we don't use assign before? So if you only use assign keyword, then only it drives continuously. That right side operation works to the left side operation. That assignment driving takes place only when we use assign keyword. So it actually creates combination logic. So before that logic won't be created if you use directly like this. Only if you use assign means, then only it will create combination logic. And see, some more rule is there here. Cannot assign to reg type. So if you define reg A, okay, so if we use assign A equals to AND of B, you are doing operation. For register type, we should not use assign keyword before. Okay, directly we can take A is equals to B. If you are defining it as input, or if you're defining A as output, just output you define. So then we have to use assign. If you define A as reg, no need of using assign keyword. Like that you have to follow the, like this. Sometimes you will get bugs. We can we should not remember this basics. So like that. So we should not use assign keyword for register types. So for wire data types only we have to use assign keyword. See. So hardware implementation example. So we are taking a just small example. So here actually y is equals to A and B or C. So how many OR gates, AND gates are created here? So there is one AND gate and one OR gate. Totally it's look like what? So we are defining like this. So A and B. First A will be like this. So what the output we are getting, that can be taken with the OR operation or with the C, A, B, C. And output what we are defining Y. Like this hardware will be implemented with a small line of code. So is AND and OR gates will be created. So for overall, what the final hardware? It's a combination logic. Here we are not using any flip-flops, D flip-flops. So we are not implementing any clocks and all. So just here we are we are studying combination logics only. So see, here if you use, what happens if you use multiple continuous assignments? So here temp, actually they declared they are doing AND operation, and again they are taking temp variable here, and they are doing OR operation. So how many hardware blocks it will create? 2 hardware blocks. So one is like AND operation is going on, and that AND operation can be taken as input to the OR operation again. So totally 2 hardware blocks will be created if you synthesize it. So let's take if we are checking, so we are writing logic. So we will give, let's take, we are implemented RTL design here. So RTL design is nothing but what are the logic you are writing. For RTL design, you have to give some inputs, right? For checking the behavior and all. So actually it's giving perfect output or not, we have to drive some inputs. That inputs can be driven, like inputs are nothing but 1 or 0, 1 or zeros. That inputs we should drive through TV. Okay, then RTL will produce outputs that can be observed in simulation part. This is actually normal verification. Okay, then we will proceed for synthesize. Synthesis is nothing but what? Actually this whatever the hardware code we written, that can be converted to the gate level netlist. So just we are writing the logics here, but that should be created, that should be converted to again transistor level, right? So that's the process is known as synthesis. Okay, and see, just we now up to now we are declared, we just revised about only 1 bits. So input we discussed about reg, we discussed about wire and output. Up to now just we discovered only about 1 bit data types. We are just manipulating 1 bit only. Now onwards what we are discussing about vector types also. So it is of what? Input is of 4 bits A. So it can able to store or it can manipulate 4 bits of data, and B also able to store 4 types of 4 bits, and output, right? So like this everywhere like this. So output also defined as 4 bits. So like this manipulation will take place. So as you know, and if you use AND means 4 AND gates will be used. So as I said before, here if you are using what you call bitwise AND means, so automatically 4 hardware, so 4 AND gates will be created like that. So here what? Next topic we are going to like combination circuit example half adder. So we are slowly entering into the basic, just we are gates completed. So just model as assignment, take every gate implementation using Verilog. Try to complete the assignment. We are going to provide assignments in the LMS portal also. Just try to work on them. Try to implement. I will give the demo of the tool maybe tomorrow evening. Up to that, just work on the codes and all, how the code behaves like. So see, here we are assigning AR XOR B, and here A and B. You know, right? You know the truth table of full adder or half adder. Go to the digital topics. In digital topics, so many circuits you worked, like full adder, half adder, mux, and even comparators, decoder, encoders you worked, right? Just refer the Verilog like digital part. There you can have Boolean expressions, right? As according to the truth table, you know what are the Boolean expressions you will get. So simply we will just write the logic. We will take extra keyword and we will write the logic. Automatically the hardware is implemented. Like that you can perform. So before properly working on Verilog part, just refer every Boolean expression of digital circuit in digital electronics. Then you are able to write easily the Verilog part and all. And see, full adder you know. So AX or BX or C is the sum logic, as well as carry logic is like this one. So if you do this one, automatically the hardware is implemented. And let's discuss common mistakes what we actually you do. So see, as I discussed before, assigning the reg using assign. So you should not use assign keyword if you declare that any variable as reg. So these are common mistakes, try to avoid them. Missing assign keyword. See, if you are declaring it as input without reg, so we should use assign keyword as I said before. So you have to use that one, don't just remember that one. And if sometimes you will get the confusion between logical operations and bitwise operations. Just try to get clarified with that. And forgetting vector sizes. So in the problem actually, let's take the problem is given, declare A as 5 bits. Sometimes we will confuse what 5 bits means, how to declare. Some students will declare 5 down to 0. Assigning that let's take input 5 down to 0. This is not 5 bits, this is 6 bits. Okay, in the register we have like this, 0 onwards we have to start, and it's ending with 5. Totally how many we will get? Here 3, here 3, total 6. So just avoid that confusions before working on vectors and all. And see, so difference between simulation versus hardware. Simulation is nothing but what? Whatever the inputs we are giving to the RTL, we are able to observe in the waveforms. That's actual simulation. Hardware is nothing but whatever the input, whatever the RTL design we designed, that is able to convert to the gate level netlist, and then it proceed to the physical design, and there are so many steps after our synthesis. So that is actually hardware design. So just know the difference between what is simulation, what is hardware. So see, simulation checks functionality. Functionality, see, as I said before, there is design, there is TB. We will drive the inputs from TB to design by instantiating our design in the TB. That we will discuss further. Just now, revise all the Boolean expression for the digital circuits and try to perform small operations. Tomorrow we are going to discuss how to perfectly simulate and check the simulation in the Xilinx Vivado tool. And see, synthesis. Synthesis converts code to hardware. As I said before, synthesis is the process of converting our whatever the code we written, that is converted to the hardware. See, assign becomes real logic gates. So if you don't use assign, it won't convert to the real logic gates. Only you have to use assign before it converts to the real logic gates. And industry interview questions, sometimes for checking basic knowledge also, interviews throw these basic questions. How many AND gates actually created? See, there are 2 designs actually. So it's actually basic code. By this, sometimes to check the basics, they will throw these types of questions. We can easily check. Sometimes manipulated. This is actually just 2 lines of code. So sometimes they will give 6 to 7 lines of code. They will say what is the total number of gates formed. So you have to fastly analyze it and you have to say that. And see. Let's have interaction now. So I think my voice is audible to all. So does assign creates hardware? Anyone please respond. If you use assign keyword, it will create hardware or not?
No.
Okay. Difference between logical and bitwise? What's actually logical? What's actually bitwise? What's the difference between them? Anyone?
Logical is used to compare 2 operands.
Okay.
Bitwise performs like bit operands.
Okay, you are saying okay, logical checks, it's actually true or false. So true or false is nothing but it's a 1 or 0 you are saying. Right, alright, very good. So assign works with wire or reg. So this is an extra question. So as I said before, if you use assign, will it work for reg or wire? For what it will be used? For what it will works actually? Works is nothing but without getting any simulation error, like that. So can we use assign for wire, or why where for what we have to use assign, wire or reg? Okay, Varsha, you are answering. Deepika, can you please answer for this question?
Yes, sir.
Yeah, yeah, Deepika, you are audible.
Where wire
Just
is used for a continuous,
yeah, okay,
where reg is used for a procedural assignments.
okay. So can we use assign for reg?
No, sir.
Okay, all right.
Sir, for wire we can use assign, sir.
Yes, yes, yes. Can register without assign we can work also. So
Yes.
see, continuous assignment is sequential or combinational. So you are using continuous assign, right? So whether it develops sequential circuits or combinational circuits. So Lokesh,
Combinational.
Varsha, okay. Lokesh, Kishore, are you there? Lokesh, okay. Shushma,
Yes, sir.
yeah, Shushma, please answer this question. So continuous assignment is sequential or combinational? Like what if you use continuous assignments, what actually it will develop?
Sir, it is a combinational.
Okay.
Means it updates the output immediately.
Okay. Whenever the output will change, it like exact at the time it will updates the like that you are saying.
Yes, sir. Whenever the input is changed, then the output will be updated immediately.
Okay. Okay. Like at what time? At zero simulation time or that time when we are updating? So let's take at hashtag 10 we are updating.
Yes, sir.
So at that same time it's updated. You are saying.
Yes, sir.
Okay. All right. That's it for today's session, guys. So let me go for LMS portal now. So actually we are able to monitor your diaries and all, what actually you are working on. So what you worked, it's updated or not. Today actually date is 16. So no one actually submitted the diaries. So just avoid this, guys. So tomorrow onwards or today onwards, try to fill this one. At least with single line is okay.
Actually, we are entering the diary in LMS portal also, sir.
You are entering.
Yes, sir.
Okay, okay. But it's not showing here. So we'll check with the technical team. Okay. And see, guys. Here I provided an assignment here. So I think you also got this assignment. Try to complete this assignment before 18th and try to submit the assignment in a PDF form. So we will see the answers. Just a written part is enough. No need of simulations and all. No need of tool outputs. Just write your answers and submit your assignment. That's it, guys, for today's session. Try to work on assignments, and then next session we are going to discuss the sequential circuit implementations, and mostly tomorrow evening I will took the tool introduction, how to use the tool. That's it, guys. If you have any doubts you can ask. And don't miss tomorrow's session. Tomorrow we are going to discuss the tool demo, how to use Verilog, like Vivado, Xilinx Vivado. And everyone, please try to install Vivado. If you are unable to install, please take your friend's support to install the tool and follow the installation video I provided in LMS. That's it, guys. If you have any doubt, you can be there, and or else you will leave the session. Thank you so much.